Okay, so this is nothing but the critical tables of the output window of SPSS, where we have tested all the 5 assumptions of multiple linear regression. So what are all those assumptions? These assumptions are like, no multicollinearity. That is one assumption. So that has been fulfilled. Why it has been fulfilled? Because the VIF, okay, the one which is mentioned here, it is lesser than 10. Okay, that's the critical value. The second assumption is that there should not be any kind of autocorrelation. That means no autocorrelation. Okay, so the rule of thumb is that the Durbin-Watson value should be between 1.5 to 2.5. So if it is lesser than 1.5, we call it as positive, and if it is above, we call it as negative. And then the concept of homoscedasticity, which talks about the variance, the variance of the error term should be constant, and we found out that this was also constant. The third assumption has also been fulfilled. The fourth one is the normality of the residuals. So this one we have tested using the normal PP plot, okay, and we have also tested it using the Shapiro's Wolf test, and we found out whether the p-value is above 0.05 or not. So that was also been tested. And the last but not least, in fact, that was the first one that we have tested, is about the linearity of the model. So the linearity of the model also we have tested, where we found out that the previous day closing price and the previous day opening price is highly correlated with, or it is having a positive relationship with next day opening price. So all those 5 assumptions, okay, all these 5 assumptions are actually being tested. So just have a look at all these 5 assumptions. All these 5 assumptions are being tested, and these assumptions are more or less similar to other kind of parametric test, with only one difference. Okay, here we are testing the normality of residuals in this case, but when it comes to the other parametric test, I mean tests like independent sample t-test or ANOVA, those kind of tests, instead of we testing the normality of residuals, we will be testing the normality of the dependent variable. Okay, that's the main difference. Okay, apart from that, all other tests are similar, right? So now we have got into a critical place where we have to interpret, okay, interpret the output. That is where we are actually doing this multiple linear regression. Now, coming to the interpretation of it, you just have to look at the table, the first table. Are you all with me? Are you able to see the screen, my screen, or are you able to open the screen that you're having, so that we can discuss about the interpretation? How do you have to interpret the multiple linear regression? Just have a look at the screen. I have zoomed it. Okay, so now this is what we call it as the main table of multiple linear regression. So through this table, we will be able to write the multiple linear regression equation. So what is the normal equation of multiple linear regression? The equation is y is equal to a plus bx. Okay, so I can use a, b, whatever it is. So here a is the intercept, a is the intercept, all right, and b is the slope, that means the coefficient, and x is the independent variable. This is for the simple linear regression. When it comes to multiple linear regression, we will be writing y is equal to a plus b1 x1 plus b2 x2. Okay, here b1, b2 are coefficient. In fact, this one closely resembles the table what we have got. All right. So now here the y is nothing but, what is the y here? Y is nothing but the next day opening price. Y is the next day opening price. Intercept is nothing but the constant. Okay, constant is the intercept. B1 is the coefficient. X1, okay, X1 is the previous day closing price. B2 is the coefficient of previous day opening price, and X2 is the notation. Now, how do I substitute it? Now we can type of equation. One is the unstandardized equation, and the another one is the standardized equation. Standardized equation. right? So one is unstandardized equation, the other one is a standardized equation, right? So when it comes to the unstandardized equation, we have to write it like this. We just have to substitute the respective values in this main equation. Okay, this is the standard formula for multiple linear regression. Now what is y here? Y is nothing but previous, that is next day. This y, we can also put it as y and later we can use it. Okay, here what is meant by a? A is the constant. Okay, what is the constant here? It is 1905.6. 1905.6 plus b1 x1. Okay, what is b1 here? It is 1.032. x1 I can put it like x1. Okay, not to change because x1 it is understood, which is nothing but the previous day closing price plus, right, it is minus 0.149, that is minus 0.149. Okay, put it as x2. All right, so now that's it. So now what I have done is that I have substituted these values. Okay, so I have substituted these values in multiple linear regression equation, and these values are the values of unstandardized coefficient with the constant. Now similarly, I can write the standardized equation. How do we have to write? Apply the same method. Y is equal to, of course the constant is not going to change whether it is unstandardized one or the standardized one, so you can have the same constant, which is 1905.6. all right, plus okay, standardized is, what is the value? 0.318. okay, 0.318. x1, what is x1 here? x1 is the previous day closing price, and 0.292, 0.292, which is x2, right? So here y is nothing but, y is the dependent variable, which is nothing but next day opening price. Okay, next day opening price, and x1 is equal to, x1 is previous day, okay, previous day closing price, previous day closing price. Okay, x1 is previous day closing price. Okay, then what is x2? x2 is previous day opening price, previous day opening, previous day open. Now I have got the equation for both standardized and unstandardized one. All right, so you can either interpret the standardized one or unstandardized one. It is up to us, right? Now how do we have to interpret this? Okay, let us interpret this unstandardized equation, right? This one. Now what does this equation says us? What does this equation says us? It indicate that when x1 increases by 1 unit, y increases by 1.032 unit. This is how you have to interpret it. Okay, we just remember this way of interpreting this multiple linear regression. You have to consider this coefficient of x1, okay, which is nothing but the unstandardized coefficient. Okay, all right. Here, then how do I have to interpret this x2? When x2 increases by 1 unit, y decreases by y decreases by minus 0.149. All right. So this is how we need to this is how we have to interpret it. Okay, now when we are interpreting this unstandardized one, probably we may not be able to make any sense because it is not in the standardized form. We can also interpret the okay, here, sorry, 1 minute, 0.11, sorry, and here it is minus 159, right? So now what is critical here is it is not about whether you interpret standardized one or unstandardized one. You have to remember this formula. You have to remember this format. You can make your note of this particular format so that you can use the same wording in your dissertation or in your research paper. What does it indicate? The first one talks about the positive relationship that x1 has on y, which indicate that when x1, that means when it goes up by 100%, that means when x1 goes up by 100%, y has its impact, it goes up by 103%. So now this is what we call it as the positive relationship that exists between x1 and y. When it comes to x2, when x2 increases by 100%, y decreases by minus 14.9%, in fact 14.9%. So now this talks about the negative relationship that exists between x2 and y. Here, point to be noted is that x1 indicate that the previous day closing price, and x2 indicate that it is the next day opening price. We can easily come to a conclusion that the x1 is having a higher impact on y. Why indicate that? So what is the conclusion? So now we have a choice. Do we have to consider the previous day opening price or previous day closing price to predict the next day opening price? Our research says that we have to give more importance to previous day closing price compared to previous day opening price, because the strength of the impact is very high as per the unstandardized as well as the standardized regression equation. Anybody is having any doubt? Anybody is having any doubt? Yeah. I want you to just remember this format. Okay, remember this format. Okay, many of us we go wrong with the format. You can also write it in terms of percentage. Instead of you mentioning it as 1 unit, you can mention it as 100%. And instead of you mentioning it as 1.032 unit, you can mention it as 103.2%. So either you can mention, the choice is up to you. Anybody is having any doubt on this multiple linear regression? How do we have to write the equation and how do we have to interpret the equation? Is it okay? Can we go to next? Yes, no? I think I myself has to give answer for this. Okay, I assume that when you have got it, so I'm going to the next topic, right? So till now we have done the multiple linear. We have done two type of regression. One is that simple linear regression, and the another one is that multiple linear regression. Now, apart from this, there are three more type of regression which is there, which we are going to discuss today. Of course, we won't be able to discuss those three type of multiple regression equation. For that, I'm going to share a data set to you so that you can use those data set for the analysis purpose. Okay, so now I will share that particular data, which is in wait a moment. I have okay. Okay, right. So I have shared you the file which you can use it. All right. So I think you would have got it. So I'm sharing that file in the WhatsApp also. Just give me a moment. So you can open that file, and we are going to discuss a concept called stepwise regression, including forward, okay, backward, hierarchical regression. Just wait, yeah, okay, right here we go. A minute, we'll share it.
Sir, one more thing, sir.
Tell me, sir.
Sir, simple linear regression is also called as a linear regression. Both are same, sir.
Sir, linear regression, it is a broad concept. Okay, we broadly classify them into simple linear regression and multiple linear regression. When I say linear regression, I meant both simple as well as multiple.
Simple, multiple, linear.
Yes, simple linear regression, multiple linear regression. When we are using only one independent variable, okay,
Dependent
okay, and studying it is simple linear regression. When you are studying multiple independent variable, trying to find out the impact on dependent variable, that is multiple linear regression. Now, apart
Sir, now
in linear regression, sir,
tell me, sir.
tell me, sir.
So the correlation coefficient ranges between the +1 and -1.
Sir, correlation can be positive or negative. It has a range from -1 to +1, correlation range.
Okay.
If it is minus, it is negative. If it is plus, it is positive. If it is very close to 0, that means no correlation. Right? Now,
Okay,
why
sir.
do we go for regression from correlation? Correlation talks about whether there is a positive relationship or negative relationship, or whether there is no relationship. That is where we go for correlation. Why we go for regression over correlation is regression tells us which is the independent variable, which is the dependent variable, what is the strength of the impact, how much it has impacted, all those things that regression will do. That is where we go for regression.
Sure, sir. Sure, sir.
Yeah. So understand the application, sir. See, what I always say that understand how to interpret, understand the application. If you forget the path, absolutely not a problem. You can refer it. Absolutely not a problem. More importantly, which test I have to use for what data. That is what the crux of the story is all about, right? Then only you will be able to design the questionnaire accordingly. In fact, let's say that maybe when you're writing a research paper, you may be having something in your mind. Okay, I'm going to use factor analysis, I'm going to use regression, I'm going to use multiple linear regression. Now, if you're having that thought process in your mind, you have to we have to design the questionnaire accordingly. So what is the data that you're going to, what test that you're going to use? If you're having something in your mind, you have to design the questionnaire accordingly, right? So that clarity that we need to have at the beginning of the research itself. If at all, if your questionnaire is not supporting, then we will not be able to use any advanced analysis technique, right? So now I think you would have got, okay, now have you got this interpretation, sir? Okay, if at all, if somebody can tell me, I'll be very happy. It will give me some kind of satisfaction. Because this is the table, okay? This is the multicollinearity table. This is the main table of linear regression. What I have done here is that this is the equation for multiple linear regression. Now here A is the constant. So I have mentioned the constant here. What is the constant here? This is the constant. This is the constant, right? And B1 is the unstandardized coefficient of x1. Okay, that is 1.03 that I have mentioned here. And what is the unstandardized coefficient of x2? Which is minus 0.149 that I have mentioned it here. That is how I was able to write the equation of unstandardized equation. After that, I have interpreted it. Okay, this wordings, this format, you please make a note of it. All right, so that you can use a similar format in your research paper also, or in your dissertation also. Right. So now, as I have told you, now we are going to discuss about 2-3 more forms of regression. Okay, and so that you will get some clarity. For that, I have shared you one dummy data. Okay, so actually it's not a dummy data, but this is this data that we have not generated. Okay, it is already available. That data I have shared it to you. Now in this data, I am actually going to study what are all the we are considering anxiety as the dependent variable, and we are going to consider gender, subject, goals, okay, and subject matter, okay, all those things as the independent variable. So this is the achievement is the dependent variable, anxiety, gender, subject matter, goal, anxiety, these are all some of the independent variables. Okay, so this is what the code is all about. Here we are going to understand some one type of regression called stepwise linear regression. Okay, so when we are talking about multiple linear regression, if you can look at this word file which I mentioned here, you can see that we have considered both x1 and x2 simultaneously. Okay, simultaneously, and we are studying the strength of the impact of x1 as well as x2 on y. But there is a way there where we can test the impact one by one. That means first we will add x1 and see what is the impact of x1 on y, and then we will add x2 and see what is the impact of x2 on y. Thereby we will be able to come out with a very strong model. Now if you consider this a particular model, okay, so if you consider this particular model, you can also see a value called r square. I don't know whether it is there. All right, is it there or not? R square, which talks about the percentage of explanation that it provides. Now here in this dummy variable, in this dummy coding, I'm going to explain you about what is the impact that each and every variable can create individually, and when it is being added with some other variable. So for that, there are basically four type of regression is there. One is that forward, another one is that backward, and the third one is that there's a stepwise regression, and we also have one more thing called hierarchical regression. Now this hierarchical regression, the researcher will decide which variable that I need to add first, second, third, fourth, and fifth. In forward, backward, or stepwise regression, SPSS will decide which variable has to be added first, second, third, and fourth. Right. So now first let us do this stepwise linear regression and analyze the output. So for that, you have to go to analyze, okay, analyze, go to regression, and go to linear. If you go to linear, I'll bring all the values towards the left hand side. Okay, I was just practicing with. Right now, as I have told you, that achievement is something that I'm considering as a dependent variable. Okay, what I'm studying is that the impact of gender, okay, subject matter, goal, anxiety. Okay, I'm studying the impact of these three things. Now I feel that my previous literature, it says that gender is having a significant impact on achievement. So first I will study the impact of gender on achievement. After that, I will add two more variables. Those two variables are subject matter expert and goal. This I'm adding. This is block 2. And then I'm adding third block, which is nothing but the anxiety. Right? So basically, I have not added all these three independent variables as one go. Rather, what I have done, I have added in block. One block, I have added gender. Then I will study the impact. Then I have added subject matter and goal, that is S mint and M goal, second block. And third one, I have added the anxiety, right? In statistics, by default, you will find this model fit will be there. Along with that, you please add R square change and descriptive. Durbin Watson, we need not to do that right now because already we have studied this. Plot, no need to do, all right? Click on OK. Once you click on OK, you will be getting the SPSS output window. I'll show you. Okay, right. So now this is the regression output window. If you can look at it, if you can look at this, right? So here you can see that we have basically got 3 different models. Just remember, when we talk about the multiple linear regression, we have got only one model. We have got only one model. Okay, but look at this. There is only one model we have got. Okay, which is R square, where 60.868. Okay, only one model we have got. But here we have got 3 models. Can somebody tell me why we have got 3 models instead of only one model? We have got 3 models because, yes, sir. Yes.
Sir.
Yeah, tell me.
Sir, is it because 3 blocks we have selected?
Yes, correct. Now, what has happened is that, see, let me tell you very simple. Let's say that there are some, let's say that I am the only trainer for this 5-day workshop. That is, we are studying the impact, that is simple linear regression. If there are 3 or 4 trainers and then we are studying the effectiveness of the training, let's say one trainer is talking about research methodology subject, another trainer is talking about literature review, another person is talking about, that is multiple linear regression. This hierarchical regression, what it does, first it will consider only me, that is block 1. Then the second trainer plus me, block 2. Third trainer plus 3. So that means it will add one by one. So you may have in the second block there are only 2 variables, but these 2 plus the first one it will consider. In the third block we have considered only anxiety, but when it comes to regression, I mean the hierarchical regression, it will consider all the above blocks also. So that means I am adding one above the other, like a top up, right? That is the reason why we have got 3 models. And believe me, it really makes a lot of sense when we are dealing the analysis. The reason being, let's say for example, if now here we have actually collected the response of previous day. No, look at this. Look at this. Now this is the equation that I have got. Now we found out from this word file that the closing price of the stock is having a higher impact on the opening price. Okay, when it comes to the opening price, previous day opening price, the strength of the impact is less. But when we are adding these two, this previous day opening price, it will have an interacting effect on the previous day closing price. Thereby, the strength of the impact might come down also. This is where the role of logistic regression comes into picture, where I will test the impact of each and every individual variable. If I have 3 variables, I will test the impact of variable 1, then model 2 is variable 1 and variable 2, then model 3 variable 1, variable 2 and variable. That's what it is done here. Now look at it. In the first block, I have added only the gender. Now that is what we call it as model 1. Now here R square, okay, R square is nothing but the percentage of explanation that a particular independent variable is giving for the dependent variable. That means what is the dependent variable here? The dependent variable is achievement. So 0.159 indicate that you just have to multiply with 100. That means 15.9. So what is the explanation for this? The explanation is that it indicates that 15.5% of 15.9% of explanation for y is given by the x. So this gender is able to explain 15.9% explanation. Okay. Now, do we have to increase it? Yes, we have to increase it, because then only we'll be able to predict what is the determinant of the achievement. Right now, we are able to determine only 15.9%. That is predominantly because of the gender. We wanted to improve it at least to 30 to 40%. Now, what is happening is that I'm adding two more variables, that is goal and as well as subject matter. If somebody is having a goal and if somebody is having a subject matter, now say for example, I may be a subject matter expert on data analysis. If I'm having a goal clarity, along with gender, clarity in the goal, subject matter, my scores has gone up. That means it has gone up from 15.9% to 40.6%. So that we can find out what is this adjust. This is change. What has happened is 0.247 change. That means you subtract 0.406 minus 0.159, you will get this value of 0.247. So that means there is a greater impact. Okay, the percentage of increase is more when I'm adding this. And third one is that when I'm adding anxiety along with the other three independent variable, it is further going up from 0.406, that is 40.6% to 45.8%. Right? You can look at all these three values of significant, because when you look at this last column, significance F, it is coming 0.004, 0.000, and 0.042. All these things are lesser than 0.05, which indicate that there is a significant impact of these independent variable over the dependent variable. Now, you as a researcher, you have a choice. You as a researcher, you have a choice. Now tell me that which model that you will consider for your research paper. Will you consider the model of gender, or will you consider model 1, model 2, or model 3? You are conducting a research. Okay, you are doing data analysis. Which you feel that is a good model? Model 1, 2, 3, or which one?
Model 2, sir.
Model 2 seems to be better. Of course, somebody might argue that the R square is more in model 3 because it is 0.458. In model 2, the R higher the R square, always it is good. What is R square? Just multiply with 100, which is nothing but the percentage of explanation. Now, model 2 is better. Why it is better? When we talk about regression, of course, there is a concept called parsimonious, which means that you need to have minimal number of independent variables, as minimal as possible. You can't add 100 or 200 independent variables. It should be 3 or 4. Lesser is always good. So when you are adding anxiety, though it is increasing, the percentage of increasing is very, very less. For that reason, given a choice, I would prefer to go for model 2. Now, in this case, who has added the independent variable? I have added, because you have seen me, I have added gender in block 1. In block 2, I have added this M goal and S mint, which is nothing but goal and subject matter. And I was the one who has added anxiety. Just recollect this. SPSS did not do anything. Now, I want to outsource this job of adding, I don't know which one is highly impact or which is not impactful. I wanted to give this task to SPSS and see what output that I'm getting. For this, I'll go to, again, dummy coding, go to analyze, regression, linear. Okay, remove all this, remove this. Now, I will add all those independent variables: gender, S-mint, M-goal, anxiety. All these are independent variables. Now I'm going to use something called forward regression. Okay, forward regression. Right? These options are already chosen by default. That is R square change in descriptive. Continue and click on OK. Now, in this case, I have not added individually, but don't expect that you will be getting only one model. Now here also, how many models we have got? How many models? Okay, one minute. Okay. Right. Now, can somebody tell me why have I got 3 models this time also? Because this time SPSS has added. Now you may ask why it has added gender as the first variable, because it will add those variables. It will add those variables which is having a higher impact. So it says that a person gender determines whether a person achieves or not. So which is having a significant impact. Then M goal and S mint comes a second. And then third comes gender, M goal, S mint, and anxiety as the third one, right? Okay. Now this is what we will be able to find it in this forward one. So that means it will keep on adding, right, without any removal. The reverse is backward. Okay, that means analyze, regression, linear. Earlier we have chosen this forward. This time I'm choosing backward. Right. In backward, if you can look at, you will find only 1 minute. Okay. So sure. Okay, I'm rerunning the model because still waiting for the output. Regression, linear. Okay, ready. Just waiting for the output. For some reason, it is not showing the output. I will rerun this. Give me a moment. Close some of the windows so that we'll get the output. There's too many windows. Regression, linear, choosing backward. Yes, this time I got it. Now, you can see here that here I have got 2 models. Okay, why 2 models? So here, first it will consider the models by considering all the variables. Then it will consider the model, okay, by removing any one variable which is of least important. Okay, that is what the use of this backward. So basically, what I'm saying is that basically there are 2 different kind of. I mean, in fact, 4 different kind of models are there for doing this regression. One is that the logistic. One is that the hierarchical regression. In hierarchical regression, what we have done is that we have selected the model one by one. Okay, we have added gender, and then we have added SMINT and M goal as block 2 and anxiety, and we did find out the effect of one by one. And then we have chosen the forward, where we have given this task of adding the order, which one should be number 1, number 2, number 3 to SPSS. And third one is that backward. In backward, first it will give the overall output by including all the independent variable. Then it will remove those variables which is not very much significant, and it will give you the value, right? So you can try with all those combination. There is also one more way is called stepwise regression is there, which is also more or less similar to forward regression, right? But the main difference is in stepwise we will be able to remove certain things. Okay, we will be able to have 4 different models. Okay, if you can come down, if you could recollect, in forward we had only 3 models. In stepwise we will be able to have 4 models. So that means it will not, so it will exclude certain things which does not have a high impact. Look at this. In model 4 it has not included M goal, but in model 1, 2 and 3 this M goal is there. In model 4, the reason why it has not included M goal, which is one of the independent variable, is that if you are adding M goal, the predictive power will automatically come down. So that's one reason. So this stepwise regression is also more or less similar to forward regression. The main difference is that in stepwise regression, we will be having more number of models compared to the forward one. Forward one, if something if we find out to be insignificant, we will be removing it. That's the main difference between these two things, right? So hope you would have got some understanding of about linear regression. Generally, at a beginner level, they go with simple linear regression and multiple linear regression. If you're looking for some kind of advanced linear regression, then you have to add the independent variables in order. Okay, this order can be of any form. It can be in the form of, if you're choosing the order, then it is a hierarchical regression. If you are giving it to SPSS in the fashion add 1 by 1, that is forward regression. If at all you wanted to remove 1 by 1, that means it is backward regression. If you wanted to include those variables which is not having significant one, then you go for stepwise regression. Is it clear? Can we go to next one? Ma'am, is it clear? Are you following along with me? Anybody is having any doubt?
Sir.
Yes, sir.
Sir, actually, you have to given that data. That means questions. But how will you take
Yes,
that?
Tell me, sir.
You have the given the data.
I have shared that SPSS file with you in the WhatsApp, right?
Yes, sir. But
Have
I
you
will
opened that?
choose which one is correlation and regression. How to find the data to convert it.
Sir, have you opened the data in the SPSS file in your laptop? Are you able to see a window like this? The one which I'm seeing, are you able to open this? Did you open the data that I have shared it to you in your laptop using SPSS? Are you able to see
Yes,
this
sir,
window?
Yes, sir. Yes, sir.
Now, in this window, you find something called achievement is there. There is one justice symbol is there. No, something called achieve is there. Achieve.
Yes, sir. Yes, sir.
That achieve is a dependent variable. Okay.
Okay.
That means this achievement. Okay. These are all the factors:
Okay.
anxiety, goal, M goal, yes mint, gender. So somebody's gender will determine whether he will be an achievement-oriented person or not. Somebody, whether he is a subject matter person, will determine his achievement. Somebody is goal-oriented person, determines the achievement. Anxiety determines the achievement. Right? Now, what I am teaching here is, okay, when you are considering all these independent variable, okay, and when all these independent variables are acting or impacting the achievement, that is multiple linear regression. How did we do? We go to analyze, regression, linear, we choose all these options and we choose this enter. Click on OK, you will get the output and whatever that we have discussed yesterday. Okay, this is multiple linear regression. Now I wanted to study the impact of each and every independent variable one by one. First, I want to add gender. Okay, then find out the impact of gender on achievement. Then I wanted to add yes mint. Then I want to add M goal. Like this, I wanted to add one by one and study the impact of first variable, then first and second variable, then first, second and third variable, then first, second and third and fourth variable on dependent variable. This I wanted to study. For that purpose, I will go for either forward, backward, stepwise, or this hierarchical. The choice is ours. Don't get carried away by the path, sir, but understand the application of it. Why I'm going for stepwise. If you're not comfortable with this one by one approach, if you are at the beginner level, go with multiple linear regression or simple linear regression. Job done. If you are going for some advanced level technique, then use these kind of tricks what I have told you. Clear, sir?
Yes,
Are you
sir.
getting, sir? So the application and the concept is very much important. Path, don't worry on that. Okay, you can refer this recorded session. If you are not comfortable using this forward, backward, stepwise, absolutely not a problem. Stick only to multiple linear regression alone. Okay, we have added all these independent variable now. Choose this, enter, and click on OK. You will get the multiple linear regression output. And how you have to interpret the output, that I have already told you using this Word file. Fine. Okay. Now can we go to next one? Ma'am, Priya ma'am, you were telling something. Is it clear? Priya, Vinesh ma'am, are you listening? Can we go on to next topic? Okay, fine. So the next one, what we are going to discuss it, we are going to use the old data, okay, the one which I have shared yesterday. All right. So the SPSS training data I have. Okay, 1 minute. I was doing something. Record now. All right. So now here, if you go for this data, okay, if you go for this data, now this was the survey data which I have collected from you yesterday. This survey data, it talks about your age, height, weight, gender, marital status, income class, whether you have taken COVID vaccine, okay, what is your confidence, all those things it is there. Okay, gender, you please put it in the form of code. If it is in the form of male and female in the form of string, please don't have it, because for some reason SPSS will not analyze if it is in the form of string. So you copy this, okay, in case, okay, if it is in the form of string. If it is in the form of string, you choose this option, okay, you will get these numbers, copy these numbers, okay, paste it in this Excel, again copy that in Excel and paste it here. You will get it in terms of number, where 1 indicate that male and 2 indicate that this female. Okay, if you're not doing it, you can also listen it to me. That's more than sufficient. Now I would like to check people whoever has reported their height in terms of centimeter. I wanted to check whether the height, especially for male, whoever has reported, is it actually matching with the national average. Basically, I wanted to check the male participants, whoever has reported their age, are they above average or below average? Now, this can be tested using a technique called one sample t-test. How do we do that? Go for analyze, compare means. Okay, there's an option called one sample t-test. Now through one sample t-test, you can actually compare your mean with that of some of the standard values. Say for example, national average height of Indian. Okay, national average height of Indian men is 5.8 feet, which is coming close to 177 centimeter. Now here we do have a mix of participants who are male and as well as who are female. Okay, now male we have coded it as 1 and female we have coded it as 2. Now we wanted to analyze the height of male, is it above or below the national average? That's what we wanted to figure it out. Now for that purpose, I need to filter only male. That means I need to exclude those females so that I can analyze the height of only male. How do we do that? Go to data, Then you have an option called select case. Okay, select case, and then there is an option called if. Okay, if is there, go to if. Okay, I will bring it towards my left hand side so that it is easy for you to understand. Here you will have the options. Now I wanted to filter only males. So that means I'm bringing gender towards the right hand side. Only male means here I have given number 1 for male and number 2 for female. So that means gender is equal to 1. Okay, click on continue, click on OK. Right? So what does it signifies? I will be considering only those male genders. I will not be considering those female genders. Now you can see that you can see the stripe mark on all the females, and I have considered only males. Now I'm going to compare the height of male with that of the national average. Compare means, okay, analyze, compare means one sample t-test, right? Height, I have brought this height towards the right hand side. Test value, I have considered it as 177. Why? Because the national average height of men is 177 centimeter. For that reason, I have considered it as 177. All right. So now, no need to do anything. Just click on OK. Right. Now we have got the t-test output. In this output, you can see that the height of men is 168.65. That means the average height of men who are in our class, that is 168.65. Totally there are 11 men. Average height is 168.65. Standard deviation is 1. So now we are actually trying to figure out whether this height is approximately equal to the national average, which is 177. According to the sample, okay, we wanted to check whether it is matching with the national average. Can we generalize that the men in our class are at par with the national average? So for that, I need to create a null hypothesis. What is the null hypothesis here? The null hypothesis is the mean height of our class is equal to the national average, which is 177. Means H0 is equal to 177, right? This is null hypothesis. Alternate hypothesis, H0 is not equal to 177. Now we have to look out for the p-value, that is the sign value. If p-value is lesser than 0.05, we are actually rejecting the null hypothesis. If p-value is above 0.05, we do accept the null hypothesis. Now in this case, if you look at the p-value comes 0.041, which means that we are actually, okay, we fail to, we fail to reject the null hypothesis. We fail to reject the null hypothesis. Thereby, we accept the alternate hypothesis. 1 minute. Okay, I'll come down. Yeah. 1 minute. 1 minute. Yeah, it is 0.041. So that means we fail to reject the null hypothesis and we accept the alternate hypothesis that it does not match, right? So what is the takeaway is that there is a difference is there when it comes to the national average of height for men and as well as for the national average. So what is the conclusion? The conclusion is that it is not very much closely related. That is the conclusion. That means probably we may be a little bit smaller because you can see the gap. The gap is 168 and the other one is at 177. Fine. All right. So anybody is having any doubt? All right. So now the other technique is that we can go for comparing of means across independent sample t-test. Okay, independent sample t-test. Now, independent sample t-test, I wanted to check out whether the height difference is same across different genders. Now, for that, right now I have crossed all the points. Now I wanted to remove it. How do I have to remove it? Go to data and go to select case, click on all cases, and I have removed it. Right now, again, I wanted to compare the height of men with that of the women and to check out whether is it same or is there any differences there or not. So for that, go to analyze. Okay, go to analyze, compare means, independent sample t-test, bring the height towards the right hand side and bring the gender here, define group. Group 1 is 1, which is male, and group 2 is female. Options, this you can exclude it, right? Right. Now, this is the Lebanese test for equality of variance, which should be above 0.05. All right. And then this is the value that I have got. The mean height of male is 168. The mean height of female is 157. All right. So now, what is the null hypothesis? Null hypothesis is height of male is equal to height of female. Alternate hypothesis is height of male is not equal to height of female. This is the alternate hypothesis. Now, if you can look at this particular table, if you can look at this table, if you bring down, if you can look at this table, you can see that, okay, 1 minute. You can see that we have got the value of t-test. Okay, we have got whether it is there any difference between the height is there and whether that difference is significant enough or not. You can see that the significance value is lesser than 0.05, which indicate that we failed to reject the null hypothesis, and thereby we accept the alternate hypothesis. What is the alternate hypothesis? There is a difference. What is the null hypothesis? There is no difference. So we come to a conclusion that, of course, there is a significant difference is there between the height of male and female. Is it clear? Anybody is having any doubt on how to frame the hypothesis for male, female? Now, this is the data that we have used, the one which we have collected from you through the survey. Right? So now this is the application of independent sample t-test. So I have told you application of both the tests. One is that one sample t-test. What is the application of one sample t-test? I will be comparing the average of my sample, mean of the sample, with that of set of values. Say for example, I have some 10 Alto cars. All these 10 Alto cars is giving something like 18 kilometer mileage. Okay, like 18 kilometer per liter mileage. The manufacturer is claiming 20. I wanted to check whether is it achieving or not. Can we generalize it? So for that purpose, I will go with one sample t-test. So when you are comparing the mean with that of the determined value, you go for one sample t-test. Independent sample t-test, you go for independent sample when you wanted to compare across the mean, across the group. When you wanted to compare the mean across two groups, that is where you use independent sample t-test. Right now, when it comes to what is the meaning of this term, paired sample t-test? Paired sample t-test means what is the improvement in terms of the test. Say for example, somebody is having fever. Please give me practice for data. Okay, same one. Okay, I will. Okay, now the dummy one which I have shared you. Okay, the dummy one which I have shared you, that I will that you can do that. That I'll tell you end of the session. Okay. Now when it comes to the paired sample t-test, it is similar to independent sample t-test, but the only difference is here I am comparing the group not across different group but across same group. Say for example, now this is the group. What was your knowledge on SPSS before the training, knowledge on SPSS after the training? It is not two different groups like male and female. It is the same group. When you're doing that kind of study, that is what we call it as paired sample t-test. That is where I have asked one question: what was your confidence that you had towards vaccine? Okay, that is towards COVID before taking vaccine. This is one. Confidence related with COVID after taking vaccine. That is variable 2, right? So go to option. No need to choose anything. So now these are the two variables that I had chosen before and after across the same group. Okay, not two different groups. Now the value what I have got is, what is the value? It is 0.03, which is also significant. This indicates that yes, there is some difference in there in terms of confidence. If the significant value is lesser than 0.05, indicate, okay, it indicate that there is a difference is there. If it is lesser than 0.05, we fail to reject the hypothesis. Thereby we accept the alternate hypothesis. What is alternate hypothesis? There is a difference. That means confidence before vaccine, confidence after vaccine is not equal to. Okay, that is what it signifies. If it is lesser than 0.05, it indicates that it is having a significant difference is there, right? So these three things I have told you, and this ANOVA is quite simple. In one-way ANOVA, here instead of we having, okay, instead of we having, it is almost similar to paired. It is almost similar to independent sample t-test. Instead of we having two groups, if we are having two or more groups, then we go for ANOVA. Okay, so let's say same example. I'm taking this height and I'm taking this gender. Okay, and I'm clicking on OK. Will post hoc test. You can Bonferroni, right? So though it is not necessary because we are using only two groups. Let's say that if there is a third group is there, let's say transgender. Okay, in that case I may not be able to use independent sample t-test. In that case I will use something called one-way ANOVA. So what does ANOVA does is that I will compare the means across two or more groups. Independent sample t-test, it compares the mean across only two groups. Now this is the main difference between independent sample t-test and one-way ANOVA, right? So I have given a detailed explanation when it comes to the application point of view in my YouTube channel. You can refer that YouTube channel, and when it comes to workout of this problem, you can refer this recorded session also, right? So now you can see that the value that I have got is 0.03, almost the same value like how we have got it for independent sample t-test. But one-way, no. The value that I've got is 0.012, which indicate that there is a significant difference is there across male and female. The difference between one-way ANOVA and independent sample t-test, once again I'm telling, independent sample t-test, it can compare only two groups. One-way ANOVA, it can compare two groups and more than two groups also, right? This is the main difference. So right now, I think in today's sessions, we have covered the comparing mean techniques for all the parametric tests. Okay, and we have also studied the stepwise linear regression, forward linear regression, backward linear regression, and this hierarchical linear regression. So all these techniques that we have studied today. So exercise for your practice. I'm sure that you all are having this SPSS training survey file with you, which I have already shared. There is one small change that you have to do. If your gender is in the form of male and female, please convert in terms of code like 1, 2, 3. Okay, like 1 to 1 for male and 2 for female. How do you have to copy and paste it in Excel and again copy it back? You get it in this format. Now, once you are done that, then what you do is that right now we did a small exercise by filtering out the male candidate, okay, by choosing only the male candidate and comparing whether the height of male is matches with the national average of male. Now, exercise for practice is that you use the same data file, you do the similar exercise for female. That means you filter out this male, you choose only female, and you check whether the female height of our section is matches with the national average of female. Now, how do we figure out? So go to national average. If you for female, you can see it is 152 centimeter. So in that value, you have to put 152 centimeter and try checking out. So this is for one sample test, and try doing it, and let us discuss about. Don't need to have too many exercise. Try doing the exercise. Let each and everyone does and see what was the result they're getting. Yeah. So anybody is having any doubt on today's session? Any specific doubt?